What's going on, everyone? You're back with Jono for another quick math lesson. Today we're going to learn another form of linear relationship, or how to write something if we're given a little bit less information. This one's called the point gradient form. Literally, this form happens when we are given exactly 1 point and the gradient. So the point gradient form, we've got points, the gradient, and we've got to write it as an equation. In order to see where the proof comes from for this point gradient form, we need to really delve into what the gradient actually is. So we know that the gradient is the slope or the steepness of the line, and we know that we can work it out by finding m is equal to rise over run. But to put this in slightly more mathematics terms, we know that it's the change in y every time there's a change in x. So one way we can write this is that the gradient is equal to y2 minus y1, that is the change in y, divided by x2 minus x1, or this is the change in x. So because of this, if we have been given the gradient and we've been given the point, we can substitute some really important information into this formula. So for this one here, I know for a fact that m is equal to 3. The gradient is 3. And I have 1 point. I don't really know what the other point is, so I'm going to keep that y2 as just some number. That is just y minus y1, which we've been given in the formula. So here I've got y minus 2 all over x. Again, I don't know what that other x point could be. It could be anything. Is just going to be x, and that's minus 1 from the question. So now we've got quite a bit of information with an x and a y variable that could represent anything. This is exactly where we want to be. This is what our other forms look like, where we've got coefficients with an x and a y variable. So what we want to be able to do is simplify this, right? I don't like having a fraction on one side. It makes things a little bit more complicated, but we could really expand this out to see something quite easy. If I wanted to get rid of that fraction, I've got to multiply both sides by x minus 1. So I'm going to do that straight away. So this becomes 3x minus 1 is plus 1. All is equal to y minus 2. Because they're equal, I'm actually going to switch them around and then expand that x side straight away. So this is y minus 2 is equal to 3x plus 3. Now to get y by itself, because that looks a little bit more simple, all I have to do is plus 2 to both sides, which is equal to y 3x plus 5. This now looks exactly like our normal form. We've got y is equal to 3x, or the gradient multiplied by x, plus 5, which we know is the y-intercept. So now we've got the full equation of a line just from 1 point and the gradient. So you're not going to be asked to show that proof every single time. All you really need to know is the formula. And the formula is that y minus a y point is equal to the gradient all multiplied by x minus an x point. So if you've just been given 1 point and the gradient, you can work out what the equation of the line is going to be always. So we're just going to see an example here. You might be asked to find the y-intercept of a line just from a point and a gradient. Instead of graphing this out and eventually finding out where it goes through, if you can turn the information you have from our point gradient form into our gradient intercept form, or that y equals mx plus b, you're going to be able to read the y-intercept off immediately and have to do way less work. So for this one, we know we've got a line that goes through -2 and 3 and has a gradient of 9. If I sub these values in, I can rearrange this into y equals mx plus b super quickly. So this is y minus 3 is equal to the gradient 9, x, not minus 2, but it's minus 2, so it has to be plus 2. From here, I just have to expand out and move and get y by itself. So this is y minus 3 is equal to 9x plus 18. Plussing that 3 over to the other side will give me y is equal to 9x plus 21. So therefore I know for a fact that the y-intercept is at 21. Once you've done this, We've got heaps of information from there, and we've changed this into an equation that we can use incredibly easy. So this should show you that once we've got a point and the gradient, we can use that information incredibly quickly to find out what the equation of the whole line is. This will help us find out other points, distances, all the other things that we've learned so far in linear relationships can be achieved just with this quick change of form. Thanks so much, guys, and I'll see you later.